Dear friends, organic chemistry is a very important branch of chemistry and it primarily deals with organic compounds. Organic compounds, as we simply define, are the compounds mainly comprising of carbon and hydrogen elements. They are diverse classes of organic compounds mainly because of the unique nature of the carbon atom and its tetravalency. So there are various permutation combinations possible which also leads to various isomers, and so millions of organic compounds are formed, are available in nature, are synthesized, and therefore is a vast number. To deal with that, we have a special chemistry called as organic chemistry, and it becomes imperative to understand how these compounds are classified. So therefore today we are going to have a short discussion to deal with the basic classification of organic compounds. The learning objectives will be mainly to know the different types of classes of organic compounds. We are dividing organic compounds for our understanding into 6 major classes. Compounds containing carbon, hydrogen atoms only, mainly hydrocarbons, which involve alkanes, alkenes, alkynes, aromatic hydrocarbons, uralkyl hydrocarbons, and alicyclic hydrocarbons. Second class is compounds containing additionally oxygen atoms also. So under this group fall the alcohols, phenols, ethers, epoxides, carbonyl compounds, aldehyde ketones, carboxylic acids, esters, and anhydrides. Third class is containing nitrogen atoms besides carbon and hydrogen. Under this fall amines, imines, nitriles, hydrazines primarily. Fourth class is compounds containing carbon, hydrogen, and halogens, which may or may not also contain oxygen, like the alkyl halides, aryl halides, and acyl halides or acid halides. Fifth class is compounds containing carbon, hydrogen, oxygen, and nitrogen atoms. Many a times oxygen may or may not be there, but nitrogen is very much there. So amides, imides, alloxymes, ketoxymes, nitrocompounds. Then we have what compounds containing carbon, hydrogen, sulfur, with or without nitrogen, oxygen, and halogen. Sulfonic acid, sulfonyl halides, sulfonamides. Our next lecture we will deal with their nomenclature, but today we will see very systematically how these compounds are classified and what are their subgroups. So this is a schematic showing classification of carbon compounds into 2 types. It's acyclic or aliphatic open chain compounds and closed chain or ring or cyclic compounds. Under cyclic compounds you have got carbocyclic or homocyclic compounds like alicyclic and aromatic compounds, and you have heterocyclic compounds. Other way of classification is into 2 major groups, simple hydrocarbons and substituted hydrocarbons. Under simple hydrocarbons you have aliphatics and aromatics. Again they are divided into saturated and unsaturated. As far as aliphatic compounds are concerned, the saturated you got alkenes, which can be again alicyclics, acyclics and cyclics, while in unsaturated or non-saturated you got alkenes and alkynes, which can be further classified as acyclics and cyclics. And under hydrocarbons which is substituted you got oxygenated hydrocarbons, nitrogenated hydrocarbons, halogenated hydrocarbons. Under them, under oxygenated, you get acids, alcohols, aldehydes, ketones, esters, ethers, phenols, salts. Under nitrogenated, you have amides, amines, azo derivatives, you got hydrazines, you got hydroxylamines, you got imines and nitriles. And under halogenated, you have got alkylaryl halides and acyl halides. Let us see these classes one by one and their subclasses. Under compounds containing only carbon, hydrogens or the hydrocarbons, you get alkenes, which are totally saturated with a molecular formula of CnH2n plus 2. Under this you have got methane, ethane, propane, N-butane, isobutane, and let us see they have different prefixes N, iso or neo. Under what conditions these are given? Say for example, if it is a straight chain compound without any branching, it is given N prefix, so it is N-alkane. If it has got a methyl group at the second carbon, it is called as iso. And if it has got a carbon which is a quaternary carbon which is attached to 4 different carbons, it is called as neo. So the carbons can be classified into 4 categories: primary carbon which is attached to only 1 carbon, secondary carbon which is attached to 2 carbons, tertiary carbon which is attached to 3 carbons, and quaternary carbon which is attached to 4 carbons. This is depicted here. Primary, it's attached to only 1, this is attached to 2, this is attached to 3, and this is attached to 4. We have second subclass cycloalkanes. Some examples are given here like cycloalkane, cyclopropane, cyclohexane, etc. You have got alkenes with one unsaturation, so naturally 2 hydrogens are removed, so the molecular formula becomes CN2H2N. Examples are ethene to isobutene. You add one more unsaturation and convert it to triple bonds, you get acetylene and you get phenylacetylene and several examples, and the molecular formula again loses 2 more hydrogens, so CnH2n minus 2. Aromatic hydrocarbons with conjugated double bond systems, these are cyclics essentially, and they have 4n plus 2 pi electrons. Benzene, naphthalene, anthracene, phenanthrene are the examples. You also have substituent alkyl groups on a benzene ring or an aryl ring, so these are called as alkyl compounds. Toluene, ethylbenzene are the examples. Coming to the class number 2, which is carbon, hydrogen and oxygen compounds, we have several subclasses, mainly alcohols with the general formula ROH. These are monohydric, dihydric and trihydric alcohols depending on the number of hydroxyl groups. Monohydric can be again classified as primary and secondary and tertiary depending upon the OH group attached to the primary, secondary or tertiary carbon atom. You got phenols where the OH group is attached to the aryl ring. You got examples of phenol, catechol, resorcinol, quinol, orthocresol. You got ethers where there is a O linkage to which 2 different alkyl or aryl groups are attached. If they are the same, they are called as symmetrical ethers. If they are different, they are called as unsymmetrical ethers. Examples are dimethyl ether, ethyl methyl ether. Epoxides are cyclic ethers. Examples are ethylene oxide or simple epoxide to propylene oxide, dioxane 1,4-dioxane, tetrahydrofuran. There are some typical compounds with very symmetrical and very typical shape in the structure, like crown, resembling crowns. These are called as crown ethers. Example, 18 crown 6. 18 denotes the number of total atoms present in the molecule and 6 denotes the Number of oxygen atoms on similar lines, you have 12 crown 4 and 15 crown 5. You got carbonyl compounds, a very important class of subclass of carbon, hydrogen, oxygen containing compounds with a diverse range, starting with aldehydes, ketones, carboxylic acid, esters, anhydrides, and acid chlorides. Aldehydes have a functionality CHO. These are the examples, starting from formaldehyde to the benzaldehyde. You can also have substituents on aldehydes, and the carbons adjacent to the aldehyde functionality are designated as alpha, beta, gamma, and so on. You got ketones, which have a carbonyl CO attached to two same or different alkyl or aryl groups. So you have got acetone, ethyl methyl ketone, benzophenone, acetophenone. Carboxylic acids can be monocarboxylic acids or dicarboxylic acid depending on the number of carboxylic acid groups. Formic acid, acetic acid, propionic acid, butyric acid, benzoic acids are the monocarboxylic acid, while you have oxalic acid, malonic acid, succinic acid, glutaric acid, phthalic acid are the other examples of dicarboxylic acids. You have esters like methyl formate, ethyl acetate, diethyl acetate, so methyl butyrate. So in the ester, the R dash is pronounced first, methyl, and then acetate, ethyl, and then acetate. Anhydrides, you have cyclic anhydrides like acetic anhydrides, and you got cyclic anhydrides like succinic and malonic anhydrides. You have the third class of the organic compounds containing nitrogen atoms, nitrogen element besides carbon, hydrogen, primarily the amines, and they are primary amine, secondary amine, tertiary amine. These are usually ammonia derivatives, and if one hydrogen of the ammonia is replaced with an alkyl or aryl group, they become primary amines. These are the examples from methylamine to aniline. And if two hydrogens are replaced, they become secondary amines, dimethylamine, you got diphenylamine, ethyl-methylamine. Tertiary means all three hydrogens are replaced, and so you get a tertiary amine like trimethylamine or triphenylamine or ethyl isopropyl methylamine. If you still press one more alkyl or aryl group to the tertiary amine, it becomes quaternary ammonium salts. If one of the hydrogen of the amine is removed, a double bond is formed. These are imines. Example is diphenyl methylamine. Nitriles are separate functionality with a C triple bond N functionality. Example methyl cyanide acetonitrile. If the position of nitrogen and carbon is reversed and the carbon is made terminal and nitrogen is attached to the alkyl or aryl substituents, these are called as isonitriles or isocyanates. The hydrazines are NH, NH2. These are derivatives of simple hydrazine. Depending, they can be alkyl hydrazines, they can be aryl hydrazines, they can be di-substituted hydrazines. Compounds containing carbon, hydrogen, halogens with or without oxygen are alkyl halides, aryl halides, acyl halides. Simple alkyl halides are, of course, bromoethane. This is benzyl bromide. You have aryl halides like chlorobenzene, bromochlorobenzene, and you have acid chlorides, which are also called as acyl halides, acetyl chloride, benzoyl chloride. The fifth group is, of course, comprising of oxygen, nitrogen both. The major group is, if you replace the OH of the carboxylic acid group with NH2 or substituted amino group, they become amides. Example, formamide, acetamide, benzamide, urea. You have imides, that is, one H is again replaced with another carbonyl group and cyclized, succinimide, phenamide. You have aldoxymes coming from aldehydes. The oxygen is replaced with um, hydroxyl amino group, and we have ketoxymes similarly from ketones, and we have nitro compounds like nitromethanes, nitrobenzene, etc. Compounds containing carbon, hydrogen, oxygen, nitrogen, sulfur, and halogens. Basically, three important categories. Sulfonic acids. SO3H is a sulfonic acid group, which is similar to carboxylic acid group. You got methane sulfonic acid, ethane sulfonic acid, benzene sulfonic acid, and much more diverse compounds like sulfanylic acid and saccharin. So these are amides. These are little bit cyclic. This is cyclic amide of the sulfonic acid, imide actually. And you have sulfonamides, of course, very diverse, very rich, medicinally active collection of sulfonamides is there, mostly antibacterials. The simple sulfonamide, similar to carboxamide. These are the various derivatives by replacement of the hydrogen of the free amino group. You have sulfonyl halides like acetyl halides or acyl halides. So you have got benzene sulfonyl chloride, you have got chloramine T. So, dear friends, the next time we will deal with in another lecture the IUPAC nomenclature system for these organic compounds. I think the broad classification of organic compounds and their subgroupings you have understood well. Thank you very much for your patience and diligence.